welcome. In this video, I will explain how to evaluate a cross-section of a sciatic nerve obtained from rat experimental model. And ideally the best way is using a stereo investigator software and make the calculations using the software. But in case you don't have it, we will use Fiji application, which is free to download from web, and it's really easy to use. First of all, we need to take the picture of the whole nerve. This is an image taken at 10x magnification. It doesn't matter, you can take it at 4x magnification if you wish. The important thing is to cover the whole nerve as much as possible. Also, please don't forget to put your scale on the image, because we are going to use it to set the scale while using the application. And yes, after taking the image at 4x or 10x magnification, just focus on 40x and starting from the upper left part of the image, we need to sample the whole nerve without any intervals at 40x magnification, and we will evaluate all these images one by one. Please don't use any interval. Take the whole nerve as careful as possible. And after sampling at 4x magnification, you will approximately obtain 15 images, which is suitable for stereological counting. If you obtain between 15 and 20, it should be fine, and your images will be like this. Let's start to application. I always start with the one taken at 10x or 4x. It depends on you. First things first, you need to calibrate the scale of the image. Go to straight line bar in here and draw a straight line just in the upper part of your bar. You can click to the shift to make it like super straight. Go to analyze, set scale. Our known distance is 200 micron. And okay. Now all we need to do is just outline the othermost part of the nerve, and you can actually use this measure tool in here, or Command M. There's a shortcut, Command M. I always use Command M because I'm using Mac. I think in other computers is Control M. If you click to Command M, you will see the area of the whole nerve in here. Just copy and paste to an Excel sheet. Actually, I will send you this. I will upload also this for you. And this is your total area of the nerve. Each Excel sheet belongs to one group, and approximately in experimental models we have between like 8 to 10 animals, so you can add more animals to here as you wish, or you can delete. We will record the axons counted in one frame to this line. This is gonna give us the summary of all these axons. And also we will record the myelinated thickness, myelinated nerve fiber area, and other things, etc. Now we're done with this one. I will proceed with one of these images. As I told you, you can randomly choose one. Okay. So the magnification of the image now is changed. We need to set the scale again from the scratch. Straight line. Okay, set scale. Now our noun distance is 50 micron. I will click to global to make it uniform in our further images. Then with the help of this, you don't need to set the scales from beginning for each image. So we are fine now. Now what we need is the counting frame. There's a tool in ImageJ, this grid tool. We can use one of these squares as a counting frame. And for this example, I'm going to use a counting frame 4D microns to 4D, which the area of the counting frame is going to be 1600. That should be fine. And after doing this, I will just randomly choose one of these squares as a counting frame. The important thing in here is if you're choosing this one, you need to choose the exact same frame in your further images as well. You cannot just use this one in one, that one in another image. No, that's not the best way. I usually choose the one in the middle. For this example, I'm gonna choose this as my counting frame. I will just focus. Yes, this one is okay. Please remember that the rules of the counting frame also applies in here. That means these two lines are the excluded one, which means if axons, one of the axons are hitting these lines, one of these lines, it's not countable. You couldn't include it in your countings. And these two lines are included one, the vice versa applies in here. So we can use this multi-point tool in here to counting quickly how many axons we have in here. I'm not sure about this one. Another point in here, you can see that there are newly baby sprouting myelinated nerve fibers in here. It depends on you, but if you would like to count these axons, actually this is the nucleus of the Schwann cells, I guess. Yeah, this one is the myelinated axon. It's better to evaluate them separately because it can lead to misperception in your countings. So I prefer to count these already existed myelinated axons in here without including these newly sprouting ones. So I have 10 in here. I'm going back to my Excel in the table, and the results obtained from my first image and from my first counting frame is 10. So you will do the same countings for your further images, and please record your results one by one in here. And the next box in here will automatically calculate the summary of all these values that you recorded in here. Now I'm going back to my counting frame. We haven't done in here yet. Click to Shift A and delete all your points. The thing we are going to do now is measuring the axon area and myelin sheath thickness. In order to do this, it's up to you. You can choose just one axon on the upper right corner of your frame, or you can just count 4 from each side. It depends how precise calculation you would like to do. For this practice, I will just choose the one in the upper right part. I will take the line bar in here and just draw a line. Command M. And the length automatically appears in here. Another line in here, Command M. Another here, Command M. Another here, Command M. Okay, now we have 4 values obtained from this myelin sheet. I will copy and paste in here. This 4, I will take the arithmetic mean of these 4 values in here, which is 1.761. 1.761 is the myelin sheath thickness for my first counting frame. The other measurement I can do it here is measuring the axon area. You can just use this polygonal tool in here, Command M. This is the area of that axon. We can just take easily from here, copy. Yes, this one. So this is all I can get from my image for this. For this practice. Now we will work on the Excel sheet a little bit. Now I have the total axon. Let's assume that I've counted the other counting frames as well, of course from the other images. And the Excel calculates the sum of all countings. And now I need to know how many myelinated axons do I have in the total section. Like how many myelinated axons I have in the whole nerve. So how we are going to do, what we need to do is simply this. This article, I can put the link of this article for you. This article explains very nice how to evaluate a nerve section and how to calculate the sampling fraction. The sampling fraction is the area of unbiased counting frame divided by the sampling area. What was my unbiased counting frame? It was 40 to 40, which means the area of this my frame is 1600, and also I need to obtain the area of the sampling frame, which is the area of my sample. Like I did use this sample. Yes. Oops. Sorry. Yeah. Okay. Remember that. Okay. We used this as a counting frame, so the area of my counting frame is 40 to 40, 1600. Now the area, I need to calculate the area of our sampling frame, which means the area of this whole image that appears in front of me. So I'm gonna use the straight line tool again. Command M. Command M. So now I have, yes, this is the length of first line and this is the second. So if we multiply these two, we are going to find. Now I'm going to calculate the area of the sampling frame. Which is this multiplied by this, and the area of my counting frame was 1600. Now, what was the sampling fraction? If you remember from the article, this sampling fraction was the area of unbiased counting frame divided by the sampling area, which means sampling frame divided by the sampling area. But we are going to use the inverse of this value, which means 1 divided by the sampling fraction, which means 1 divided to sampling fraction. Yes, this is the value that I'm going to use in here in my Excel. Just let's paste the values. Yes. Now the thing happening, what's happening in here, we need to multiply the total axons with 1 divided to sampling fraction. Yes, this is your estimated myelinated axon number. For the rat, they're in a control, if you are counting a control group, the number of myelinated axon is between like 7,000 to 10,000, and our number is appearing like this in here. Of course, these results now in here just made up results. You will see your actual results in your samples. You can ask me if you have any questions about table or about the countings. Thank you for listening.